Hello guys, I am Vishnu. So there was a considerable gap between the last video that I posted. It was actually drug-induced liver disorder series. So today I am coming with a new series. This is related to pharmacology and it is known as diuretics. This is actually a very big concept. So before we directly go into diuretics, obviously many of you know about a lot of diuretics either through your hospital duties or you have studied theoretically, whatever it is. But I personally believe that we should learn the basics first, and then we will go into the application aspects. So first we will talk about the normal anatomy and physiology, the basic functions of the nephron, as to how fluid and electrolyte regulation happens in each functional zone of the nephron. So we'll talk about that, and then we will talk about how individual diuretics act on individual areas. So let's go into the presentation. So as we know, the mission of our channel, books are available everywhere. You'll get notes and PowerPoints everywhere. But whatever material that you have, how you are going to interpret it into a practical aspect with easy to remember concept, that is the challenge that we face nowadays. So this channel and the educative videos that we share with you helps to address those issues. So please support us in our mission. So welcome to an ocean of practical knowledge. There are a lot of people who actually want to connect with me, and many people don't know me personally. And most of you have seen that you have a lot of doubts regarding your career, the subjects that you have, and how you are going to study it properly. You're not getting the proper exposure, or maybe you have cleared your exams, but you don't know what to do with the knowledge that you have. Or many of you have memory issues. All these confusions can be addressed. So you can just contact me at my email ID. The email is given here. Or you can contact me at LinkedIn also. LinkedIn is a very popular website through which a lot of people like us get connected with a lot of other people around in a professional basis. So if you are having any confusions or you need a clarification regarding pharmacology, therapeutics, toxicology, case presentation analysis, as in how to present a proper case, how to take a case and how to analyze it. That's also important, because unless you do that, you will never be able to present a case properly. It will just be a mere formality. How to study practically, because many of you have loads of theoretical knowledge, but you don't know what to do with it. If you want to discuss any case that you encountered in the hospital with me, if you want to know about pathophysiology, because pathophysiology means you are learning about the anatomy and physiology first, and then you will understand what happens when those anatomy or physiological features are damaged. That is called pathophysiology. And definitely, if you want to know about normal lab parameters and what are their clinical significance, like for example, if sodium rises, what are the symptoms? How will you? What are the conditions in which sodium rises? What are the conditions in which sodium level falls, etc., etc. So if you want to know all these things, or if you want me to have a talk on all these things, then definitely you can contact me at this email ID, and you can contact me at LinkedIn as well. So when we talk about fluid and electrolyte regulation, 16 to 20% of blood plasma that enters the kidney is filtered from glomerular capillaries into Bowman's capsule. So this is just a very theoretical statement. Let's come into the practical part. So the filtrate means the substance that is remaining after filtration process. So the filtrate consists of glucose, it can consist of bicarbonates, amino acids, electrolytes, etc. So the functional zones in the nephron that are involved in fluid and electrolyte regulation include, we have a proximal convoluted tubule, which is known as PCT. We have a descending loop of Henle, ascending loop of Henle, distal convoluted tubule, which is known as DCT. And then we have a collecting tubule and collecting duct. So we are going to talk about each of these anatomical areas. what are their functions, and what are the effects of the drugs that act on this particular functional zone. So this is just a summary of the thing that I was talking just a few seconds back. You can see individual, there are some numbers given here in black. So the first number is proximal convoluted tubule, which comes first. Second is the descending loop of Henle. Third is the ascending loop of Henle. Fourth is the distal convoluted tubule. And the fifth is the collecting tubule and collecting duct. So before I talk about individual anatomical zones, please remember you will get images like this as you see on the right hand side. So in all images, you will be getting about either PCT, DCT, ascending limb, descending limb, whatever it is. But there are two things that you should always, whether it is any image in this presentation. One is the lumen and the other is the interstitium. Lumen means it is the area where urine is produced, and interstitium is the area where blood is present. So in normal condition, what happens? Urine is formed, but there are a lot of essential elements and water that should be reabsorbed into the blood to maintain osmolar equality. So this is what usually happens. What does diuretics do? They prevent this reabsorption from the lumen into the interstitium. So all the things get excreted through the lumen, and that gets eliminated through urine. So this you will find in almost all pictures. So you can remember it in that way. So the proximal convoluted tubule is found in the cortex of the kidney. It's the first part of the nephron. Almost all glucose, bicarbonate, amino acids, and other metabolites are reabsorbed. 65% of filtered sodium and water is reabsorbed. This is a huge number. And that is why many of you may think that any diuretic that is acting on the proximal convoluted tubule will have superior efficacy because it will eliminate the reabsorption of 65% of filtered sodium and water. Well, it is a hallucination, it's a delusion, because we'll talk about that later, why diuretics acting here are actually weak diuretics. The proximal convoluted tubule has a high water permeability. That is why so much large amount of water is being reabsorbed. So 60% of water is reabsorbed from the lumen to the interstitium to maintain osmolar equality. The reabsorbed sodium is brought from lumen into interstitium via a pump, which is known as sodium potassium ATPase pump. So this is just a channel which helps in the reabsorption of sodium from the lumen that contains urine into the interstitium that contains blood. The proximal convoluted tubule also contains an enzyme which is known as carbonic anhydrase, which modulates bicarbonate reabsorption. Means it increases the reabsorption of bicarbonate. So you can see it in the image itself. So there are two important things that you need to know. Although diuretics block PCT, the Henle's loop is present just below the PCT. So if you open the image of a nephron, you can see very well that first comes proximal convoluted tubule, then below comes the descending loop of Henle, then comes the ascending loop of Henle. So even if any diuretic is blocking the reabsorption in the proximal convoluted tubule, the elements are in urine, but it is still going through the Henle's loop. First it goes to the proximal convoluted, then it goes into the descending loop. So there is a chance of reabsorption taking place in the Henle's loop also. So these diuretics are not blocking the Henle's loop. They are only blocking the proximal convoluted. So whatever is going into the lumen, it will go down and get reabsorbed in the Henle's loop. So the diuretic efficacy cannot be achieved. And that is why diuretics that act on proximal convoluted tubule have limited efficacy. So this you have to understand the anatomy and physiology of the nephron. Only then you will understand what I am trying to say. Once again, I'll say, even if any diuretic is blocking the reabsorption in the proximal convoluted tubule, we have a Henle's loop below, which helps in the reabsorption of whatever things are there in the urine. And these diuretics are not acting on the Henle's loop. If these diuretics were acting on the Henle's loop also, then we could have said that these are powerful diuretics. But they do not. So the reabsorption will easily take place in the Henle's loop. So there is no point in using this diuretics. So these are only used in very selected conditions. We'll talk about that later. And another thing that we need to know, this is a practical knowledge. You can see in point number 2 that I mentioned, proximal convoluted tubule contains carbonic anhydrase enzyme. So you can look into the image very carefully. H2O plus CO2 in the presence of carbonic anhydrase enzyme forms H2CO3. H2CO3 is carbonic acid. From this H2CO3, hydrogen ion is getting eliminated into the urine, and the remaining HCO3 minus, that is bicarbonate ion, is getting reabsorbed into the blood. So if you are using carbonic anhydrase inhibitors, for example, acetazolamide, it is a carbonic anhydrase inhibitor. The side effect will be metabolic acidosis. So you can understand from the reason very well, because bicarbonate is basic in nature. So if you are blocking the reabsorption of a basic molecule, the opposite of basic is acidic. So that is why acetazolamide has a huge risk of causing metabolic acidosis. And that is why acetazolamide is also used in metabolic alkalosis. So these are two things that you need to understand from this particular slide. Then the proximal convoluted tubule also consists of organic acid and base secretory systems. So if you talk about the acid secretory system, it releases uric acid, some antibiotics, and diuretics from the bloodstream into the lumen. So that is why here the risk of drug interactions and side effects are very high, because you can see very well it is written that it releases uric acid. Now diuretics, for example, thiazide diuretics, what do? They compete with the elimination of uric acid through the lumen. So in that condition, they can precipitate hyperuricemia or gouty attacks. So this can be a risk factor for a patient who is already suffering from gout. And another example that has been written below, this is very famous when we study biopharmaceutics. Probenecid is a molecule. It blocks the elimination of penicillin. Now, obviously, you know that penicillin is an acidic molecule. So penicillin G, the natural penicillin, it has a very poor bioavailability because it gets eliminated rapidly. But if you are using probenecid with penicillin, probenecid will block the elimination of penicillin. So the plasma drug concentration of penicillin will be increased. Then we talk about the basic secretory system. It secretes two substances, creatinine and choline. Now we come to the next part, that is the descending Henle's loop. So this is not very significant, but here large amount of reabsorption takes place. So the filtrate from the proximal convoluted tubule passes through the descending limb of Henle and then it goes into the medulla. A high osmolarity is observed here. So the concentration of sodium and chloride increases by 3 times. And that is why I said that any diuretic that acts on PCT has very limited efficacy, because you can see it here. The reabsorption is almost 3 times. So to some extent, osmotic diuretics act here because osmolarity is observed here. So osmotic diuretics have some kind of an effect here. Now you can get confused between what is osmolarity and what is osmolality. There are two terms like that. Osmolarity is the total number of solute particles per liter of solution, and osmolality is the total number of solute particles per kilogram of solvent. Now we come to the ascending Henle's loop. This is the most important area, and any diuretic that acts on the ascending limb of loop of Henle is the most powerful diuretic, and that is why loop diuretics act here, and they are considered to be the most powerful diuretics. Ascending Henle's loop is water impermeable in nature. There is a transporter or a channel known as sodium potassium chloride cotransporter. It actually increases the reabsorption of sodium, potassium, and chloride, as you can see in the image. And to some extent, magnesium and calcium also gets reabsorbed. 25 to 30% of sodium chloride is absorbed here. So diuretics, what do they do? So you can see in many books, they have written the mechanism like this, that they block sodium, potassium, chloride cotransporter. Many people, what they do, they by heart it like that. So with this image, now you can understand what is happening. Loop diuretics, they block this transporter, so this reabsorption does not take place. Diuretics that act on the ascending limb, for example, loop diuretics, they have maximum efficacy because of two reasons. Number one, this is the main site for salt reabsorption in the ascending limb. Maximum salt reabsorption takes place here, 25 to 30%. And after the ascending Henle's loop, then comes a distal convoluted tubule, and then comes the collecting duct. They are not very powerful reabsorbers. They do reabsorb, but the concentration of reabsorption or the percentage of reabsorption is very low. So if any diuretic is acting in the ascending limb, it is very powerful. Now we come to distal convoluted tubule. So this is the area where thiazide diuretics usually act. So there is a transporter known as sodium chloride transporter. So you have seen in the ascending limb, it was sodium, potassium, and chloride transporter. Here you will see as sodium chloride transporter. It is also water impermeable in nature. 5 to 10% of filtered sodium and chloride is reabsorbed. So thiazide diuretics block that transporter, as a result of which this reabsorption does not take place. There is an hormone known as parathyroid hormone. It's also known as PTH. So parathyroid hormone also regulates calcium reabsorption. The parathyroid hormone always wants that calcium level rises in the body. So thiazide diuretics also increase the activity of parathyroid hormone. So as a result of which, thiazide diuretics increase the reabsorption of calcium. So this is the difference between thiazide diuretics and loop diuretics. Loop diuretics cause hypocalcemia, whereas thiazide diuretics cause hypercalcemia. Anyways, we'll talk about those individual details and special features later. So this is just an idea that I wanted to give you. Then the last is the collecting tubule and collecting duct. So the collecting tubule and collecting duct consist of two types of cells. We have a principal cell and we have an intercalated cells, as you can see in the image. Principal cells increase the absorption or the reabsorption of sodium, potassium, and water transport into the interstitium. And intercalated cells increase the secretion of hydrogen into the lumen. So these are the functions. So principal cell brings sodium, potassium, and water from the lumen into the blood, and intercalated cells from the blood, it will take hydrogen and deposit into the lumen. 1 to 2% of filtered sodium enters the principal cells via epithelial sodium channel. So you can see it in the image. There is a channel known as epithelial sodium channel. So it is bringing the sodium from the lumen into the principal cell. And once the sodium enters the principal cell, then it goes into the blood via sodium potassium ATPase pump. This is the same sodium potassium ATPase pump that you saw in proximal convoluted tubule as well. So you have to understand what happens. Inside the principal cell, from the lumen, sodium enters into the principal cell through epithelial sodium channel. And once it enters the principal cell through the sodium potassium ATPase pump, it gets reabsorbed into the blood. So there is also a mineralocorticoid known as aldosterone. So aldosterone also has a very big activity here. Aldosterone has two actions. Number one, it increases epithelial sodium channel activity. So it will increase the entry of sodium from the lumen into the principal cell. And aldosterone also increases the activity of sodium potassium ATPase pump. So as a result of which potassium will get eliminated and sodium will get inside the blood or interstitium from the principal cell. And that is why in this particular area, that is the collecting tubule and the collecting duct, we usually use epithelial sodium channel blockers, for example, amiloride and triamterene. And we also use aldosterone antagonists, for example, spironolactone, eplerenone, etc. So epithelial sodium channel blockers, what they will do, they will block that channel. So as a result of which potassium will not get eliminated, sodium will get eliminated, the reabsorption will not take place. And definitely aldosterone receptor antagonist means it will block the epithelial sodium channel activity also, and it will also block sodium potassium ATPase activity. And that is why aldosterone antagonists usually have hyperkalemia as a side effect, because they prevent the elimination of potassium. So that is why they are also known as potassium sparing diuretics. So potassium sparing diuretics are classified into two. Number one, epithelial sodium channel blockers. Number two, aldosterone receptor antagonist or aldosterone antagonists. Then we have antidiuretic hormone. It binds to vasopressin type 2 receptors. So that also increases water reabsorption through aquaporine channels. So the drugs that act in collecting tubule and duct are aldosterone antagonist, as I said before, spironolactone, eplerenone, etc. And then we have epithelial sodium channel blockers, for example, triamterene and amiloride. So this is just an introduction into fluid and electrolyte regulation and a very small brief introduction into what does the individual diuretics do, what do they do in particular areas of the nephron. So thank you for watching this. In the next video, we will talk about thiazide diuretics in detail. And like that, we will continue each class of diuretics on each day in separate videos. So this is going to be the pharmacology session of diuretics. So please do subscribe and share to maximum people. And please stay tuned to our channel because we'll keep updating the same series on a daily basis. Thank you for watching. See you in the next video. Until then, it's bye.